Hello friends, welcome to Susan and John MathTube. In this video, we're going to learn about the derivation of the standard equation of an ellipse. But before we start, we will go through a few basic definitions and locus definitions, etc. so that you will find the derivation kind of like comfortable. Okay, I guess you remember that a mathematical cone is the three-dimensional version of pair of lines. You might have heard that the three-dimensional version of a circle is a sphere, a cube comes from a square, etc. etc. Likewise, you can imagine a cone to be the three-dimensional version of a pair of lines. Okay, so basically when you see or when you imagine a right circular cone, you can have a structure like this in your mind. But it is not pair of line. I told you this exists in three dimension. So there will be infinite number of lines passing through the same point. Okay, now what we do is we cut the cone with the help of a plane. Now suppose I hold the plane like this, then it is obvious that the cross section will be a circle. But if I keep the plane with a slight inclination, it is easy to observe that the cross section will be elliptical. And if you cut the cone on this corner, you will get a parabola. And if you cut it like this, you will get something like a parabola, but not 1, 2. And that system, it is not a parabola by the way, that system is called hyperbola. So basically you have to understand that the conic cross sections are circle, ellipse, hyperbola, and even pair of lines. If you want a pair of lines, it's very simple. You cut the cone in this manner. And if you imagine the cross section on the plane, you will be able to see a pair of lines. Okay, so anyway, this is the geometric construction. Now let's go for the mathematical side. That is the locus principle. Okay, for the locus principle, what we do is we consider one straight line, a fixed line. So what do we want first? A fixed line. And the second thing that we need is one fixed point. In some books they use the notation S, and in some books they use the notation capital F. It's up to you. So once more I'll repeat. We will take a fixed line. Once taken, we cannot move that line. And one fixed point. Now what we do is we take a moving point Pxy in such a way that the ratio of the distance between S and P divided by Pm, the distance between P and M, where M is the foot of the perpendicular of P. For example, if P is here, this will be our M. If P is here, this will be M. If P is here, this will be M. So what we do is we take SP by PM to be a constant, and that constant will be normally denoted by the letter E. Okay, once more let me explain. Consider a fixed line. Consider a fixed point. Now what you do is you take a moving point in such a way that the distance between S and P divided by the distance between P and M, where M is the foot of the perpendicular of P on the line, will be a constant. And the constant can be any number bigger than 0. Now look at this. I'll give you one example. Let's say we need SP by PM to be, let's say, 1 divided by 2. So we can understand that SP and PM has many possibilities. SP can be 1, PM can be 2. SP can be 2, PM can be 4. SP can be 3, PM can be 6. SP can be 0.1, PM can be 0.2. SP can be 100, PM can be 200. So there will be so many points, which will balance that condition. And if you plot all the points, you will be surprised, because you're going to get the same structures which we discussed earlier. That is, you will either get a circle or an ellipse or a parabola or a hyperbola. So I'll repeat for the last time. What we do is we take two things. One is a fixed line. Another is a fixed point which we denote by S. Now take the locus point or the moving point x comma y. Now look at this. This is not a fixed point. You can take it anywhere according to the geometric condition. And wherever you draw P, you imagine the foot of the perpendicular on the line, that will be M. That is, P can be drawn anywhere in the plane in such a way that SP by PM should remain constant. Now look at this. If the constant is equal to 0, you will get a circle. If the constant is less than 1 but bigger than 0, you will get an ellipse. If that constant is equal to 1, you get a parabola. If the constant is bigger than 1, you get a hyperbola. The constant has a special name. It is called eccentricity of the conic, or the shape deciding factor of the conic. And this fixed point also has a name. It is called focus. And this line, the fixed line, has a name. It is called directrix. And of course, the moving point will generate our picture. Maybe an ellipse if E is less than 1. Maybe a parabola if E is equal to 1. Depending on the value of E, it will produce a conic section. Okay, now let's start with the derivation of our ellipse. Okay, now look at this. By the way, you have to understand, the standard ellipse means an ellipse which will have center origin and which will be symmetric about both x-axis and y-axis, and the length of the major axis, that is this one, will be 2a, and the major axis will be on the x-axis. And this ellipse can be created by, you have to understand that this ellipse can be created by a fixed line on the left and a point, or a fixed line on the right and a fixed point. Anyway, I have a trick for you. That is, we will divide the proof into 5 parts. We will divide the proof into 5 parts so that you will find it very comfortable when you learn. If you look at the past year question papers of IOE, you will understand how important the derivation of ellipse and hyperbola is. And one more thing, if you understand the derivation of an ellipse, the derivation of hyperbola will be very easy. Okay, we start like this. Consider the standard xy plane. So what do we do first? We consider the standard xy plane. Now you know that in the standard xy plane, the meeting point will be 0, 0 or the origin. Now remember, we are deriving the standard ellipse. So the origin will be the center of the ellipse. Look at this. We are creating everything. Don't forget, we are creating everything in such a way that the standard ellipse will be generated. I told you earlier, standard ellipse means the center will be the origin and it will be symmetric about both x-axis and y-axis. Okay, now for the proof, what I am going to do is, I am going to consider the directrix on the left and the focus on the left. So what all things did I consider? I am considering the directrix on the left and the focus on the left. And I am going to take the moving point to be Pxy. Okay. So I'll repeat what all things I did. What did I do first? Okay, let's write. What did I do first? I am considering the standard xy plane. Now you think about it. What is special about the standard xy plane? The origin will be 0, 0. Okay, now we are going to call that point C because that will be the center of our ellipse. So let C be the origin as well as the center of our standard ellipse. As well as the center of our standard ellipse. Now look at this. What's the next thing to do? Yeah. Okay. So take or consider the directrix, that is the fixed line on the left and the focus on the left. So we are going to remember, you can do the same derivation. You can do the same derivation with the help of directrix on the right and focus on the right, but I have already considered the directrix on the left and the fixed point on the left. So I am going to derive with the help of the directrix on the left and the focus on the left. Okay, so consider the directrix on the left and the focus on the left. Let S be the focus and Z be the point of intersection of directrix with the x-axis. Okay, now we go for the hero. Let Pxy be a point such that SP by PM will be, tell me what will be the value of eccentricity? Yeah, less than 1. So how did you consider P? In such a way that SP by PM will be eccentricity, where the eccentricity will be bigger than 0 but less than 1. Where M is the foot of the perpendicular of P on the directrix. Now look at this. Now there will be many values of P. Look. And when you plot all these values, come on, tell me what will happen. If you keep on plotting all these values, think about it, what will be generated? The standard ellipse will be generated. So that's it. That's the end of part 1. So I'll explain once more. What will you write first? Consider the standard xy plane. And remember, we are deriving the standard ellipse. That means the center will be the origin. So let C be the center, and then what we do is we consider the directrix on the left, the focus on the left, and S be the focus, Z be the intersection of the directrix with the x-axis. And what is the speciality of P? SP by PM will be eccentricity E, where E will be a quantity less than 1. Now, when P moves according to this ratio, who will be generated? Exactly. The standard ellipse will be generated. So that is the first part of the proof. You can do one more thing that will help you a lot later. We can cross multiply and write E into PM. And let's call it equation 1. You will understand a little bit later why I did this. Okay. Shall we continue? Yep. Now, the second part of the proof. But before we start the second part, I'm going to show you like what you call, who is this M? Because I know some of you did not understand that clearly. Just imagine if P is here, then who will be that M? M will be here. When P will be here, You can imagine m to be here. Now think about it, m will come here, sorry, p will come here, p will come here, m will be here. When p is here, m will be here. When p is here, m will be here. And this is, I'm going to call it A. So I'm calling the vertices as A and A dash. I hope you don't mind. And one very important thing, I'm going to mark, let the distance between A dash is equal to 2A. And we know that distance from center to A is center to A dash. That's a symmetry of the standard equation. Don't forget, this comes from the symmetry of the standard equation. Okay, anyway, the point I was explaining is, if P moves, if this P can be anywhere, don't forget P is the, what you call, ellipse. If P reaches here, M will be here. 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 Like that, like that, like that, like that, like that. If P is here, where will be M? If P is here, where will be our M? If P is here, where will be our M? Like that, like that, like that, like that. It goes. That A dash is equal to how much? 2A. And distance from C to A and C to A dash are equal, where A and A dash are the vertices. Okay, now look at this. I'll ask one very important question, and that will be our part 2. Look at this. I told you when P keeps on moving, our M will keep on moving up and down. So, can you tell me what will happen when P becomes A? Where will be our M? Oh, M will be Z. Okay, that's it. I'm going to write. When P becomes A, then M becomes Z. It's obvious, it's obvious, it's just your common sense. Look, when we keep on moving, P comes here, P comes here, P comes here, P comes here, you can see M is also coming down, coming down, coming down, coming down, coming down. Okay, when it reaches A, M will become Z. So what I'm going to do is, by equation 1, what will happen? SA. See, when P becomes A, M becomes, okay, I'm going to write E into AZ. That will be equation number 2. Now I'll ask you one more question. Look at this. Our P is going here, P is going here, and you can see that M is coming along, M is coming along, and P is when P is here, it will be here. P is here, 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 and M is going up, up, up. When P becomes A dash, are you able to see M becomes Z again? So please write. When P becomes A dash, then M becomes Z again, not sad, Z. So that gives me S A dash is equal to E A dash into Z. That's equation number 3. Okay, great. That's part 2. So we had part 1. Part 1 was very colorful, the description and the picture. And part 2, we had 2 special cases. What happens to our M when P becomes A? What happens to our M? It comes down and down and down to Z. And then tell me what happens to our P when it becomes A dash. Same thing. And I got 2 equations. Okay, now let's jump to part 3. Part 3 is really awesome. Anyway, I'm going to write what I gained in part 2. SA is equal to AZ, equation number 2. SA dash is equal to E into A dash Z, equation number 3. Now look at this. Part 3 is very easy, provided you remember this. In part 3, what we do is we are going to add equation 3 and equation 2. You might be wondering, why am I writing like 3 plus 2? Normally people say second equation plus third equation. I'm saying like third equation plus second equation. Actually, I'm not bothered about addition. In this side, I'll be writing subtraction, subtracting. So I'm going to do equation 3 minus equation 2. The reason is very simple. SA dash is bigger. You can see from the picture. The distance from S to A dash is very big compared to S to A. That's the only reason I want to create, or I want to keep the distances and stuff positive. Okay, tell me what will happen when you add these two things. SA dash plus SA will give you, E comes common, AZ plus A dash Z. And SA dash minus SA gives, here you can write in any order, but here the order is very important, third equation minus second equation. Okay, now always don't forget it, note it somewhere, this is very important. While adding and subtracting, you can be 100% sure one of the sides will be A dash. Same with subtraction, one of the sides will be A dash. So let us analyze SA dash plus SA. So come on, tell me please, what is SA dash plus SA? See, I promised, that is A dash. That means in the subtraction part, this will be A dash. If you want, you can confirm it. Or let's confirm it now. A dash Z. Where is A dash Z? A dash to Z minus AZ. See, A dash. Okay, now what you do is you write, there are 4 remaining terms. Can you see? There are 4 remaining terms. Term 1, term 2, term 3, term 4. So what you're going to do is, you're going to express each term in terms of the sender. I'll give you an example. A to Z distance. A to Z distance should be expressed in terms of sender. Okay, for that, okay, this is the distance I want to cover. Look, this distance. And what I'm going to do is I'm going to write this as C to Z distance minus C to A. Think about it, you can think about it. Now A dash Z, A dash Z. Now what should I do? I should divide it into 2 parts. Sender to A dash plus sender to Z. Okay, so this and this will get cancelled. I hope you still remember what we wrote earlier, the derivation. CA is equal to CA dash. So we get 2A is equal to E into 2CZ. Cut. So C to Z length will be A by E. Equation number 4. Now we got that the right side is A dash. Now I should express this in terms of sender. S to A dash. S to A dash. Very easy. CS plus CA dash minus bracket. Okay. You can check it. It will be like this. So this will get if you want, I'll check it. CA minus CS. See, CA minus CS. That will be the distance between A and S. Okay. So what I'm going to get here is 2CS equal to E into 2A. That is the distance from C to S equal to AE. That is equation number 5. Okay, this is part 3. So let me explain once more so that you don't forget. In the first part, I told you I'm going to divide the proof into 5 parts. In the first part, I'm going to explain the picture. we took the standard xy plane. The center will be marked as C, the origin. C will also be the center of the standard ellipse which we are going to generate. And we took, to create the ellipse, we took the directrix on the left and the focus on the left. And focus we denoted by S, directrix and the meeting point of the axis is Z, and the moving point P is generated in such a way that SP by PM will be E, where E is a number less than 1, so that we are sure that an ellipse will be generated. So we took all possible values of P, and you can see that when P becomes A, this is part 2, when P becomes A, M becomes Z. When P becomes A dash, you can again see that M becomes Z. So we got 2 equations in part 2. In part 3, what we do is, we are going to add the equation and subtract the equation. You can add in any direction you like, there is no problem with that. But when you subtract, you make sure you subtract the bigger one minus smaller one. And the promise that I gave you is, one of the sides will be always A dash. And the other side should be written in terms of the center, the origin. And which gives us equation number 4 and 5. Now look at this. Now in part 4, we are going to do something very important. So first of all, tell me, if this is the origin and if this distance is like 7 units, what will be the coordinate of this point? I'm sure you're trying to tell me it is minus 7, 0. You are right. If this distance is 10 units, this will be minus 10, 0. Now look at this. I think you understood why I asked that question. C means our origin. S means the focus on the left. And we found that the distance between the origin and focus is AE. And that gives me a 100% assurance that the coordinate of S will be minus AE 0. So you can write, therefore, S is minus AE 0. And just beneath it you can write, also P is, do you still remember what is P? The moving point, the locus point? Yeah, P is XY. So what is P? What is P? Yeah, also P is X, Y. So what will be the distance between S and P, or P and S? Want it to be a root under? I think you remember distance formula. You can write X plus AE the whole squared plus Y minus 0 the whole square. That will be equation number, how much? 5, 6. Okay, now what is the distance between C to Z? A by E. Now look at this. My job is to calculate PM because we already calculated SP. Now I want PM. I think I should ask you one question before we start that. Look at this. If one point is given by the coordinate X, Y, what will be this length? Of course X. What will be this height? That will be Y. This will be X. What will be this length? It will be X. This will be Y. Why I asked that question is, can you tell me what will be this much distance? Can you see the purple distance I am marking? That will be X, right? Look, this is X, this is Y, right? Just now we discussed the logic. So look at this. The purple thing which I made will be of length how much? X. Now, what did we find in equation number 4? C to Z is A by E. Can you see? C to Z. Okay. So here I am making another picture. Come on, tell me what is this? Isn't it A by E? Look. C to Z and these are parallel. So what is the distance between P and M? Tell me please, what is the distance between P and M? Isn't it X plus A by E? Okay, you try to understand that. That's it. We have completed part 4. So Pm is x plus a by e. That is Pm is equal to, I'll take LCM, Ex plus a by e. Okay, now part 5. Part 5 is very simple. By equation 1, Sp is equal to E into Pm. You can check that equation. You wrote that earlier here. Now I can see that our Sp is in square root, right? So I'm going to square on both sides. And I'll plug in. So x plus ae the whole square plus y square. Look at this. I took the square root away because we are squaring. Is equal to e squared multiplied by ex plus a the whole square by e square. Look, I'm squaring this and I'm putting it over here. Now expand x square plus 2aex plus y e square plus y square equal to e square x square plus 2eax plus a square. I hurried a little bit. I hope I didn't make any mistake. So that's it. So look at this. There is something common. X squared into 1 minus e squared plus y squared is equal to a squared into 1 minus e squared. You think about it. Now, I think in class 12 you might have learned that the standard equation looks like is equal to 1. I'm sure that you learned with is equal to 1. Don't worry, I'm going to divide throughout by the right hand side. So we get x squared by a square plus y squared by a square into 1 minus e square is equal to 1. If you want the exact form that you learned in class 12, look at this, plus y square by, you just call this term as b squared. Do you remember? You learned the formula b square equal to a square into 1 minus e square. This is how it comes. So that's it, my friends. This is the standard equation of an ellipse. Okay, one last time before I stop the video, I'll try to explain so that things become easier. And now I'll repeat once more. Don't by heart proofs. Always understand the proof. In that way you'll enjoy writing proofs in exams more. Anyway, in the first step we describe. In the second part, what we do is we try two relations. And in the third part, we do addition and subtraction. And I gave a few guarantee. One side will be AA dash, other side should be written in terms of the sender. One side will be AA dash and the other side should be written in terms of the sender. And from here we got two things. One is the value of CZ equal to A by E. And the consequence was we were able to find Pm. And another thing we got was CS is equal to AE. And the consequence is we got the coordinate of S. So that we are able to calculate SP and PM. Now in the last part what we did is we plugged in every value into equation number 1. And we found the standard equation as we expected. Okay friends, so I'm going to stop this video right now. So if you like the video, please share, subscribe, and we'll be back soon with another video. So till then, my friends, bye.